The third three-dimensional problem I've chosen because the diagram is presented slightly differently. In this case, you have a vertical corner post, AB, and AP and AQ are two cables of equal length. Immediately, that means that this length and this length are going to be equal to each other. We are told that P, Q, and B are in the same horizontal plane, and I'm just going to shade it so that hopefully it's a little bit easier to see what the horizontal plane is in this particular case. All right, AB is my vertical post. All right, these would be my two stays that are equal to each other. In previous examples, our diagram has been drawn like that. Now, the diagram is being drawn like this. Okay. We are told that the angle between the stay and the horizontal, that angle over there, that angle there is beta. All right. So, sorry, not beta, it's theta. Okay, AB is equal to x. PQ is equal to 2x. And APQ, this angle over here, is 90 minus theta. And of course, that one over there would also be 90 minus theta because this triangle is isosceles. Notice that this time round we are not dealing with our vertical or horizontal triangle. We are dealing with this triangle that's in that inclined plane. All right, angle A, they've told me, is alpha, and each of these two angles here is 90 minus theta. PAQ is equal to alpha. Right, so the first thing we want to do is to look at triangle PAQ. Because it's an isosceles triangle, both of those angles there are 90 minus theta. So two of those plus that angle there must be 180 degrees. So 90 minus theta plus 90 minus theta plus alpha will be 180 degrees. That means alpha minus 2 theta is equal to 0. So alpha is equal to 2 theta. Often they phrase these questions like this in an exam because if you mess that up, we don't want you to get nothing for this part of the question either. So now we are looking at the area of this triangle APQ in the inclined plane. Now I know all sorts of angles in that triangle, but I have to know one length if I'm going to work out the area. And how do we go about doing that? All right, so I would like to work in triangle PAQ. The only length that I could potentially find is going to be AQ. And how am I going to find AQ? I am going to work in triangle AQB. So to start with, in triangle AQB, what kind of triangle is it? It is a right-angled triangle. Okay, that is a right-angled triangle. I'm looking for the hypotenuse. I have the opposite. So I'm going to say that sine of theta is equal to my opposite over AQ, which is my hypotenuse. A little bit of algebra here. AQ is equal to x over sine theta. Now, of course, you have got all three sides. So let's just have a look and see what is going to be the most use in terms of getting that area over there. Okay, so I'm in fact going to say that this and work with that included angle, all right, because there are no alphas in what I've been asked to prove. And so I'm going to say the area, now I'm working in this inclined plane, the area of triangle APQ is a half 2x times AQ times sine of the included angle. This is a half times 2x times x over sine theta multiplied by, and now I have to use my reduction formula. What quadrant? 90 minus theta is in the first quadrant. What axis? I'm working from the y-axis, so my ratio changes to its co-function. And when we tidy that up, we get x squared cos theta all over sine theta.